All right, let's go through this problem. We have Tarzan grabbing a vine of length 14.5 meters hanging from a tree branch. So Tarzan is 4.4 meters off the ground when he grabs this vine. He swings on the vine, and at the lowest point, he picks up Jane. And together, they keep swinging. And we want to know, oh, sorry for the jump there. We want to know how high. Oops, again. All right, so we want to find this final height. The maximum height means the speed of them over here by the time they get to this location is 0. Initially, we can say Tarzan's speed is 0. And then he swings down. So we can totally say that Tarzan initially has gravitational potential energy because of being at this height of 4 meters. We can say Tarzan and Jane together end up with a total potential energy of mgh, where we need the mass of both of them, and then g and h is what we want. Now, our first instinct is to go ahead and say, you know what, this potential energy Tarzan has initially is going to be potential energy finally. But that is not true. And we need to understand why. There is a collision at the bottom. Tarzan has swung down, he's picking up Jane, and they're swinging together. So there's a collision at the bottom of the swing. Tarzan was swinging alone, and now he is swinging with Jane. If he has picked Jane up and is holding on to her, this is a totally or perfectly inelastic collision, which means the energy in the system, the kinetic energy right after he picks her up, is not the same as he had right before he picks her up. There is always a change in kinetic energy when the collision is inelastic. But we do know that momentum is always conserved in a collision, regardless of the type of collision, which is awesome. So we can say that the mass of Tarzan times Tarzan's initial speed, meaning right down here at the bottom, how fast he's traveling right before he picks up Jane. Totally inelastic means they're moving together. And so by looking at conservation of momentum, we can relate how fast Tarzan's moving to right before he picks up Jane to how fast they're moving together after. Now, we don't actually happen to know either of these speeds or velocities. We know the direction according to my picture, but we don't know the values. So we have two unknowns, meaning we need some other equations. If we think about before, sorry, I don't know why this isn't, my computer is responding slowly. So by before, I mean, okay, Tarzan has grabbed this vine, he starts to swing. He does have potential energy initially, and it will turn into kinetic energy right before he picks up Jane. meaning the V Tarzan right before he picks up Jane is related to this kinetic energy that he has because of swinging downwards. So we can find the speed of Tarzan. We can say the mass of Tarzan, G times that initial height he is at, which we know, is going to turn into this kinetic energy. So this allows us to find out how fast Tarzan is traveling immediately before he picks up Jane. So he was 4 meters off the ground. Oops. So right before he picks up Jane, he is traveling 8.854 meters per second. That is how fast he's traveling in terms of right before the collision. That means we can find out how fast they're traveling together after the collision. So plugging in these numbers, Tarzan's mass is 70.4. Speed, 8.854, we just calculated that. Oops, not plus. Equals Tarzan's mass, shift that a little bit, plus Jane's mass. This V final is how fast they're traveling together right here at the bottom. That is definitely not the right answer. Plug something in. Oh, I multiplied. I need to divide by their combined mass. So 5.4776. Hopefully it makes sense that together they're traveling slower. This velocity represents them together right after Tarzan has picked up Jane. And they're going to swing up to this maximum height, h. Now that the collision is in the past, right, we used conservation of momentum to calculate what was going to happen because of the collision. We can now say that the kinetic energy they have together is going to turn into the potential energy they have together. So 1/2 of the total mass of them together, this speed squared is going to turn into their combined mass, G, Y final we're calling H. That combined mass cancels. So this speed squared over 2 times 9.8 is going to give us the height of the branch that they swing to together. 1.5 meters. That's how high they will swing. Okay, so we have to be careful and make sure we recognize whether or not there's a collision of some sort. The safest bet in a problem that does involve a collision is to always use conservation of momentum for the collision itself, because momentum is conserved in any type of collision. Whereas the conservation of energy, we would perhaps need to know the thermal energy generated, that type of thing, which we wouldn't know from the information given in this problem. So energy and momentum can be used, but we have to be careful in terms of when we are using it.